At Apogee, we sell a lot of PAR meters, and finding the right one can feel a little bit overwhelming. Stick around and we'll help you find the perfect PAR meter for your needs. A quick refresher for those who might not know. Quantum meters measure light. To make it simple, imagine that the light coming from the sun is like rain falling from the clouds. Our meters are like uncovering a sheet of paper out in the rain for 1 second and then counting the number of drops. Counting drops is essentially what a quantum meter does, but instead of rain, they count photons of light. A PAR meter measures the amount of light, but only in the light spectrum that promotes photosynthesis. The light in this range is called photosynthetically active radiation. This PAR wavelength spectrum is between 400 and 700 nanometers. Knowing this PAR information can be vital in growing and studying plants. It's similar to how we use calories when studying the growth of humans. Using other measurements like lux or foot candles falls short because lux and foot candles determine the amount of light that the human eye can see, and the human eye sees some color of lights better than others. The human eye is more sensitive to colors like green than we are to red. This is because our eyes use a rod and cone vision system. Unlike humans, plants see all the colors in that spectrum evenly. So if you graph the photosynthetic response of plants to light, it would look something like this. So if we wanted to measure light according to a plant's sensitivity, a perfect meter would produce a response curve that would look identical to that PAR curve. With that understanding, you have the knowledge that you need to understand the variation in the sensors that we offer. At Apogee, we produce 3 versions of quantum, or specifically PAR sensors. The first is the original X, then the full spectrum, and last, the ePAR sensor. The original X is the least expensive sensor we make, and it features a response curve that looks like this. As you can see, this response curve is not ideal, in that it overestimates the blues and the greens while underestimating the reds. It also captures a significant amount of UV light. At first glance, it might not seem like a close match to this PAR spectrum, but with the over and the underestimations being accounted for, it's not bad in terms of accuracy. At Apogee Instruments, we take pride in being a low-cost, high-science provider of measurement tools. The high science part refers to the fact that although the inexpensive sensors might not be the most accurate, we know exactly where and why they're not accurate. And with those shortcomings, we can use calculations to correct the data and make that sensor sufficiently accurate for a much lower price point. Because this sensor tends to overestimate the blues and the greens while underestimating the reds, it does not work so well for LEDs. But it does have 2 broad spectrum calibration options. One of those options is for sunlight, and the other is for electric lights, like a T5 or a high pressure sodium. This is a great lower cost option if you're specifically measuring either sunlight or these electric lights. Our next sensor is the full spectrum sensor, and this is the response curve of the full spectrum sensor. As you can see, the response curve on the full spectrum much more closely follows the PAR curve. It also catches a little bit of UV and kind of under-responds a little bit on the blue, but overall, it's really good. A sensor that can obtain a perfect PAR response is impossible to achieve, and you can spend significantly more amount of effort and time, which equals money, chasing marginal accuracy returns. This sensor is an excellent balance between accuracy and cost. Another benefit of this level of response curve is that the sensor is accurate under all lighting conditions, from sunlight to LEDs to high pressure sodiums or T5s. However, the accuracy of this sensor does come at a higher price than the original X. All right, one more type of sensor. In recent years, there has been increasing evidence that far red light found in the 700 to 750 range of the light spectrum can contribute to plant growth, especially in plant leaf size and general plant morphology. This extended range has been given the term ePAR, or extended PAR. And we have a full spectrum sensor that includes this additional portion of the spectrum. And this is what the response curve looks like. All right, now we've gone over the quantum sensors that we have available. Let me show you what formats we have these sensors in. We have the handheld, We have the DLI, and then we have sensor-only options. Let's look at the handheld meters first. The handheld meters are perfect for spot checking and automatic logging of data. It's a complete solution that requires no additional hardware or other components to operate. The handheld meter allows for a sensor that can be submerged. Not the meter, but the head can. And we have several underwater models that have correction factors applied for taking measurements underwater, like in an aquarium. With all handheld quantimeters, you have the ability to access the DLI data using the optional AC100 communication cable. Using the Apogee Connect software, you can access all the saved data in addition to the DLI measurements. The next meter format we have is the DLI meter. If a handheld meter is like counting drops on a piece of paper, DLI is like a bucket. Rather than measuring light at a specific moment, the DLI is collecting data through the course of the day. In math, an integral is a term referring to the area under a curve. So the daily light integral is the amount of light during a 24-hour period and is expressed in a term called moles per meter squared per day. In addition to the DLI reading, the DLI meter gives you instant PAR readings and the previous day's photo period. Photo period is the amount of time the light was on in the last 24 hours. When the DLI is connected to a computer with the included USB-C cable, you can access the data set with 99 days of DLI and photo period data, as well as the last 7 days of PAR data with averages over 30-minute intervals. In summary, the DLI meter is perfect for collecting DLI measurements, photo period measurements, and doing spot checks of PAR. It's perfect for outdoor use. The sensor is resistant to falling rain, but you don't want to submerge it. The last sensor format we have is the sensor-only option. This is ideal for situations where you already have a system or a method of collecting data. And we have a lot of options to match whatever protocol your system uses. So, on our sensors we have various outputs. We have analog and we have digital. In our analog options, we have a 0 to 40 millivolt option, which is our unamplified option, and it's capable of connecting with an Apogee MicroCache. The Apogee MicroCache enables app connectivity with Bluetooth connections from your phone using the app that's available. From the app, you can view data and adjust logging intervals. We also have a 0 to 2.5 volt, a 0 to 5 volt, and a 4 to 20 milliamp option available as well. In our digital outputs, we have an SDI12 output, a Modbus output, and a USB connection output. The USB option allows you to connect the sensor to a desktop computer using the Apogee Connect app. You can view and collect the data and adjust your logging parameters. The sensor then can be disconnected from the computer and then powered by a USB charger where it can then collect data on its own. If you're looking for the least expensive option, this is your best choice. But it does require a computer and takes a bit more time, and it's not quite as convenient. With the various sensor output options, we have several cable lengths, including no cable, 30 centimeter, and 2 meter, and we can even do custom lengths upon request. In addition to our standard range of sensors, we have several specialized sensors, like the light pollution sensor, which has a higher sensitivity to a wider spectrum range, but will overrange around 200 micromoles per meter squared. We also have an array sensor that will take an average reading of multiple sensors. Along with the various types of sensors, we have lots of mounts, leveling plates, and other accessories for all of our sensors. Hopefully now you should have a better understanding of what types of PAR sensors we offer. If you still feel a little lost or have more questions, feel free to call in and talk to our amazing customer support team. They can help you answer your questions and help you find the best sensor for your project. Do you want to learn more about ePAR and how the additional range affects plant growth? Consider watching this video by our founder, Bruce Bugbee. As always, thank you so much for watching and have a great day.